5.
All right.
All right.
Let's see. So I guess the big thing for this week is to talk all about the dialect stuff.
Yeah.
I guess the first step is, I guess, is the existing dialect. The one that's already been uploaded, or the one that's already being used in Substrate Go. That's the pre PR to the other one,
Mhm.
and it just gets that up. I mean, it's certainly everybody is. I mean, I had some changes to it, and then there was other suggestions for changes to it. So it's not exactly as what we're putting there is not exactly what's being used everywhere else, but or what Substrate Go is using. But we can put it what it has and then fix it in the second one.
I guess taking a step back, do you want to talk about what the dialects are, what they're for?
Okay. Okay. The dialects are basically there to I mean, it's partially there because you want to be able to control and verify and validate that a backend conforms to a particular behavior, but it's also useful for conversion to and from Substrate to SQL. I think it should be possible to do other languages, but the way it's set right now, it's very SQL centric. So those are the main uses for it. Sundeck used it a lot. Used that format a lot. So it definitely has had value for them. And I think, and I know I think I can use it in my project.
Okay, that's what I was kind of wondering, because I realized I never actually seen the dialect stuff until you merged it in, or you were bringing it into Substrate Core, and I was like, oh, wait, I thought this was an ex nihilo thing, but it turns out, no, it's a thing that exists in Substrate Go. It was never part of the core spec, which I think that makes sense in terms of that. I was going to say, do we even need to bother with your first PR, which is like merging in the Go version, or should we just go straight to like, here's the thing that we want to merge? And
Okay, I mean, I could go with that as well. Yeah, I can go with that. I mean, all the tests and everything are all the tests were in from the Substrate Go. But and you can see what the changes are between the difference between the two. But yeah,
I guess like I don't really care about the differences because I'm like I've never looked at the original format, and it's more for me. All of it is net new, so I'm like might as well just review all of it if it's net new, and you can keep.
Well, for you, but for somebody who's updating code, like going back to Substrate Go, it's nice to know what those changes are.
Gotcha.
And I think that's the only reason I go for that intermediate step.
Yeah.
Interesting. I never noticed this dialect is actually have a section in the basics. Interesting.
I guess
so,
go ahead.
Yeah. So no, I mean, can you? Is there like any very specific concrete scenario that where the dialect play a role? So, for instance, like okay, I am producer, so I produce. I mean, if we have a dialect or like or however you define, you can of course like define conformance testing of like with respect to a specific dialect, and the model is like the producer generate a specific dialect.
Let's say I mean the one use case that I've always wanted to have is being able to point to a generic endpoint, not know who heterogeneous. I have no idea who's behind it. Whoever I get, I say, hey, what do you support? And it says, I support these things, and I can write a dialect. The producer can then write the dialect that matches that. So
Okay. I
if
see.
in that case, you would have the consumer would say, hey, here's the dialects I support. And then the server would choose the dialect that it could handle and write it to that.
I see. So you are already
That's why
assuming some sort of like negotiation protocol
you would
upfront.
need some sort of negotiation protocol, and I'm not sure the dialect actually solves that particular problem. Or actually, it could be used to solve that problem, but the problem is that it's better when you know the dialect is easier to use when you know what the source
Sure.
query
Yeah.
is, right? It's like,
Yeah.
oh, I have a Spark 3.51 query. Then I can use the Spark 3.51 dialect to convert it into Substrate.
Mm.
Actually, and then I could try to use a Substrate to a 3.52 dialect. Um, um, and maybe it would work. Because most of the function names are still the same, and it wouldn't be a problem. But it would be,
Right.
Like,
yeah. I don't think it's really good for conversion in that way. And
sort of like part of this is also I was working on a similar thing for, I was calling them consumer catalogs, but it doesn't really matter, which is I want to be able to specify Data Fusion supports these functions and Substrate with these options, and there's metadata in the catalog in the dialect itself to say, oh, this maps to this Data Fusion function. And part of what I want to be able to do is be like, something only goes in the dialect if the test for that function pass, as like the conformance test pass, basically. So like right now, Data Fusion is just like, this thing is called add. I will use the add function. But if you set like add error on overflow with the overflow option in that call, Data Fusion won't do the right thing based on what Substrate is specifying. So dialects for me are a way to be like, things only get added to like the Data Fusion dialect if we can verify that they actually like map to the correct thing in Data Fusion. There's some other stuff I was testing out in Calcite where like, cool, we can have a Calcite dialect. When in that dialect, we can be like, oh, these functions in Substrate map to these operators in Calcite, which will let us do some like cool pushdown stuff in the planner. So like I want to be able to add metadata to each of like the entries for support about how to generate the mapping from Substrate to the target system as well.
yeah.
And those wouldn't be part of like those wouldn't be a shared part of the core thing because every like Data Fusion is a very specific format for its mapping. Calcite is a very specific format, but the general like, oh, this function with these signatures, these options is supported, and then extra metadata about how to map it to system. The dialects are also useful for like, we can generate documentation for command to be like, oh, you want to call Data Fusion with Substrate? Here's what it supports, like based on mappings, and not just like I have to go look at the code in Calcite or at the code in Data Fusion to see what is and is not supported.
Right. Where it gets, but where it starts getting more tricky is when you start saying, okay, well, this function, this behavior isn't the same in Substrate core, right? And so then you define your own YAML file with your own functions, and say, okay, this is the functions that work with this backend. You register those functions in Data Fusion, and now you have something that works, but that isn't good at that. That plan is pretty much locked into to working in that ecosystem.
And I think that's kind of the intended purpose of this. I mean, some of those functions could potentially be added into the core spec to be like, oh, Data Fusion supports this variant of this common function that other systems support. And there might be things that are missing in the core spec that could be added, but sometimes they're like Data Fusion or Trino or Snowflake or whatever has a very specific function that's like their own variant that only they use. And like, if the Substrate function that, I guess, if you try to map a Substrate function to a system that doesn't support it, you shouldn't do that. Which I guess is a separate problem for like, okay, when it doesn't do that, how do you handle that? And it's like, yes, David, like you can make a custom extension file for that engine with engine-specific functions, and it does like fragment the ecosystem a bit, but I think that's kind of an like intended way to do it in some ways. Like the classic one is like, I think we have add in Substrate that returns like, what does it know? It's Yeah, so the example I think is though it's division. It's like integer division returns integer versus integer division returning float, which like some systems do, right? So like
Right.
some fragment, some portion of systems will never support the like division function in substrate core because we picked one of the behaviors.
Exactly.
Yeah, but I guess David, you've got your PR. I would say just like let's just focus on one of the PRs. So I think trying to review both is
Okay.
We'll fragment them. One thing I was going to say, I think I added in my comment, what would be useful to do is actually add some verbiage to like the written spec about like what exactly a match means. Like it's like, oh, if I have this like function entry with these options, is it like, oh, only if you call it, if you invoke a function with those specific options, that's a match. If there's no required options and only like, I guess only scalar invocations with no option set match, like what exactly is like the intended meaning there?
Yeah, I think it's exactly that list is what's necessary in order for it to work.
It does get a little wonky with like, I think there's like some of the logarithm functions have like, 3 options and then 6 options. So if you actually want to like write out all the variants, it's like 12 or something. So it could get a little large, but I think if that becomes enough of a problem, we can try to figure out a way around it.
But you only are writing the ones that are required. So it's you're making this call with these options. So if you were going from SQL into Substrate or vice versa, these are the options to convert. If you had this rounding option and the conversion dialect says you don't have any conversion any rounding option, which I guess would be default, then you can't convert it into SQL safely.
Yeah, okay, that makes sense. No, I'm okay with having like 1 entry per option combination because it makes the mapping easier.
Yeah.
Cool. But yeah, I guess let's just like look at that PR and do stuff. I guess anything more on dialects?
I think this is pretty interesting concept. I actually never seriously think about it, but I should at some point. So yeah, knowing the existence is the first start. Yes.
Yes. Cool. Yeah, we can move on to the next item. I have moved something in. I have a separate PR for referencing tests in extension files. This is something that David was doing in the dialect work. So the dialects themselves could have like links to like the test files. But it's almost easier, for example, in like functions arithmetic, we say, oh, this extension has all of these test case files that you can load. Because that way we only have to add them to the extension file. And then any system that wants to load that extension, if they want to run the test, they can look in the extensions to be like, oh, here are where I can find all the tests, and I can run them. So like that would be useful for conformance testing as well. Does that make sense? Because right now we have like the test cases in like the core repo, and it's kind of like, oh, if it's in this directory, we know it maps to this function's arithmetic. But it's almost easier if we have a programmatic way of saying, oh, this extension file has links to these test cases or this directory full of test cases.
I think it makes sense. The only trick that we have is deciding whether or not we want whether we want to have the how we want to deal with different directory types, I guess. The enumeratable ones and the non-enumerable ones.
I was thinking about that. We're actually in some ways, even the references to extensions in the plans are kind of weird because they're referencing things that are not machine readable. Like if you have an HTTPS like something functions arithmetic.yaml at the GitHub, that's not really the raw file. That's like the GitHub UI link. And there's a question about like how machine readable should we make it versus like human readable.
Yeah, right now they're machine readable links.
They're not, well, sort of.
You have to know what they are, how they're constructed in order to use them.
Like, yeah, I guess if you see like a GitHub URL, you have to know like, oh, take the take the tail of it and just go to the raw content of it on. Like you have to reboot the URL basically.
Yeah.
Huh.
And that's the way we have everything else in the ecosystem. I mean, I suppose we could try to fix that for 1.0. And
Yeah.
starting here.
Yeah, I think it's that might technically be a separate thing. I think in the PR I have for the test references, I have a comment where it's like maybe we should just have like a GitHub lookup type, which is like repo name, directory name, and maybe a list of files as well to make it super easy and clear to be like, these files are part of this repo, go look for them there, and they're not just part of like a web page that you can pull from. But I think that's details. I don't think doesn't sound like, I guess, does anyone have any concerns about doing something like this, like embedding the links to tests in the extensions themselves? I think silence is everyone's in agreement. This is a reasonable thing to do. It's just a matter of like, what's the nice way to link it?
Yeah, I think that's the only thing.
Cool. Cool. We'll leave it at that. I think the discussion can happen in the PRs. Yeah. And then someone put down precision timestamp, but I'm not sure who.
I did. Precision timestamp. There's some discussion on it. So the precision timestamp time zone literals, with time zone literals, there is no time zone in the literal. So it gets converted to UTC, and then from then on, it's a precision timestamp literal. It turns out that's the DuckDB behavior. Is once it comes in, it loses its timestamp, and from there on, it's always a UTC timestamp. That's not the way that other systems work. Well, Data Fusion doesn't have a precision timestamp with time zone. Snowflake keeps the time zone around, so you have both the time and the time zone, and you can change the time zone. You can list the time zone. It's a pain in the ass. So I think because we have an implementation that works for DuckDB, it doesn't work. It doesn't make it. I don't know. Effectively, the DuckDB method is I have an implicit cast when I load it in from a precision timestamp TZ to a precision timestamp, but I still call it a precision timestamp TZ. It's a mess. So because I guess the current thing is sort of working, I think if we wanted the real precision timestamp, we wanted a Snowflake style precision timestamp with time zone, we would need a separate time. We would need yet another type. And given that Snowflake already has 3 or 4 special types it needs in order to be actually executed, it's probably not worth making this change right now. It's probably worth creating yet another timestamp that has the right semantics, or has the Snowflake-ish type timestamp semantics.
I guess in the change that you're proposing, you're basically adding a precision timestamp TZ literal, like a dedicated one, which also includes a time zone associated with the timestamp.
Right.
And that's, I guess, it sounds like DuckDB doesn't care about that, but that would, or DuckDB DuckDB doesn't need that, but other systems might.
DuckDB doesn't need it. It's something that to handle the Snowflake semantics would. Data Fusion doesn't support it, but I think that's the same. But the reason they don't support it is probably because they have the same problem that Snowflake has, which is, but or would have the same problem, but they don't have support for that type. So, and those are the only ones I looked at when I was trying to figure out what was going on last night. No, I think this is
precision
really
time zone. I just realized it's not precision time. Okay. It's really useful to know the time zone.
So just to wrap around my head like all this. So the DuckDB, when you have a literal with the time zone, it will translate it into UTC timestamp, and then it's a
UTC timestamp from then on.
Yeah. UTC timestamp. Okay, so timestamp is essentially like everything is UTC, which is like
I guess the question though is if I have a plan coming in that says, "Oh, this is actually a timestamp in this time zone," like internally, cool. Snowflake can do whatever, but we can do whatever. But if I output that result, I would expect it to be. Well, I guess in whatever it's the engine output. If it doesn't care about the difference, it won't.
Yeah, the engine is going to DuckDB is going to output it as a timestamp with TZ, but it's a UTC timestamp. So it'll be +0.
But
there's a curse question about whether that actually means that the system does DuckDB actually does that system actually support precision timestamp time zone? If it's putting it to UTC, that's just precision timestamp. Does it actually support precision timestamp TZ?
Yeah, that's what I mean, it sort of does because it can read them in, but it can't preserve them. Yeah.
There's sometimes I got a way like a case where the output
needs to be explicitly handled. So basically, if the database setting, for instance, like a SQL Server has you can set like a default database time zone, and then the time zone is assumed. So if you sending that, and then I need to convert, and then output.
It's also annoying because if you do this the time conversion, you might if you're in the second 2 o'clock, how do you know which 2 o'clock it was? You just converted it, and you've just lost or gained an hour, and and you never know because you did the translation. So I mean, it's good that you don't convert it back so that you don't have the hour, but you've already made the sin of losing the hour. So it's sort of
like as long as the system keeps whatever thing internally like consistently and understand the thing is like not without time zone. I could basically keep track of like what is the even without time zone, what is the implicit time zone that this timestamp is, then I think it's okay. But it also causes a problem in the indexing with the time zone.
I guess this breaks down if there's a way to observe externally something that's weird because of this translation, where it's like I have a system that generates a substrate plan, send it to someone to execute it, and then I send like, hey, here's system B, go read the results from the system when it's ready, and here's the schema you can expect as per substrate. And it's like, oh, that system expects a precision timestamp with some time zone, and then the output is like UTC, and I guess then the system B needs to be aware of that to be able to do the conversion correctly if it wants to present that data in the time zone.
Like if let's see. So today, if I remember correctly, in Substrate, like everything is like implicitly UTC, right? Even the timestamp literal is UTC, or am I?
I don't know.
Type system. Type class. timestamp. Oh, it's even worse. Okay. So timestamp is unspecified time zone. Timestamp TZ is UTC.
Well, I mean, basically times it. Yeah, it's true. It's
I guess what we
unspecified.
could say is like timestamp doesn't matter. Timestamp is deprecated. Let's assume that it's going to get wiped off the face of the earth.
Yeah, where precision timestamps are the two that are remaining. The regular timestamps are deprecated.
Okay. But still, like the same. Precision timestamp, unspecified time zone. Precision timestamp TZ is a UTC.
Gets converted to UTC.
Yeah. So that means like basically the system producer should be aware of this thing. Like when you express something in Substrate, like goes in as a UTC, comes out as a UTC. So you need to, if you want the result in a specific time zone, then you need to produce whatever cast, appropriate cast.
But the problem was, I mean, you already lost the data once you converted it to UTC.
What
So I
did you
mean, it's
lose?
almost better to use the unspecified time zone where it doesn't get converted.
Is this when we're storing data where we're storing both, like the data has different timestamps for each row?
It could have, you could actually, in Snowflake, you can actually have different time zones for each row, and it keeps that. In DuckDB, they all get converted to UTC, and so they all have the same.
Yeah.
Because generally you don't know the time zone when you're creating the data.
If it is in string and you're loading it, you probably you would have it. If it was arrow data, you wouldn't have. You probably wouldn't.
All right. I just mean like whatever analytics that you're doing, usually you're doing analytics like that matter in the time zone. I guess there's both cases, but
You wouldn't necessarily have mixed time zones.
yeah, I think if you want mixed time zones, that's a different type class. And if you don't want mixed time zones, you don't need the time zone at all. Then UTC is fine.
UTC is fine, and the regular timestamp, which is where it's unspecified, is fine.
Yeah. Well, so timestamp versus timestamp PZ is more about like what's your intent for analysis or something like that. I don't know. I don't like to any. Is there like a concrete question we need to answer regarding this?
I'm just trying to figure out what I'm how to proceed with that PR, and I think for now I'm just going to skip punt. If somebody who wants to have Snowflake semantics wants a timestamp, they're going to need something that looks like what I was trying to go to.
Yeah, like the one thing I can say is if there's a way to do something in Substrate where it's like I generate like precision timestamp literals with some time zone or something, send it to DuckDB and then get something out that's like in like Substrate space. Like if there's a way, then the external observer can see that wait, you threw away the time zones and you can't provide that information to me. Then I would say that's a violation of the spec in the sense that DuckDB doesn't support precision timestamp TZ in that sense. But this is like an external like violation. I wouldn't worry too much about it. Does that make sense? No.
How can DuckDB throw away?
I make a virtual table full of precision timestamps with varying time zones. I send them to DuckDB and then I get back like an arrow array and it's like, oh,
Okay.
all
When
these
you say full of precision timestamps, I mean full of Snowflake style timestamps. Like precision timestamp doesn't have a time zone.
It's precision timestamp TZ specifically.
Does not have a time zone associated with it.
I think that's
A time zone over a timestamp with fractional second expression precision.
In the current definition, it's in substrate. It's substrate. It's not. The time zone isn't anywhere. You could argue that it should be on the type. If it was on the type, then you would have a homogeneous time zone for your time zone such. Or you could have it on the literal, which means that you could have a heterogeneous mix of time zones, which is a snowflake style.
Snowflake style is on the type. It's got to be storing the time zone per row.
It is not on the type. It is. It's storing it. It's storing it as part of the data.
Yeah, it would have to be part of the data because otherwise you wouldn't be able to have a column with different time zones.
right. Yeah.
Sorry, that's what I mean. Yes.
Yeah.
It's not part of the type. It's part of the data, and it would be in the literal. That makes sense.
Right. Yeah.
Right.
So that's a new type class. We don't have that in Substrate.
Right. So that's basically, that's what I'm saying is that, we need a separate type.
Yes. I mean, that's why, we internally, we define a user-defined type for the precision timestamp with time zone. Yeah.
I mean, to your point, David, I think punting on this until someone actually needs it and they can drive it makes sense.
Okay, here's one.
Oh, yeah, you want it? Congratulations.
We can add a new type class. I think that wouldn't be too controversial. I can see it would be useful, and it would probably remove a lot of confusion if we added that new type class, because then people would say, "Oh, I'm thinking about this."
Yeah. It would be like precision time zone with mixed time zone with mixed time zones.
Isn't that what precision timestamp TZ is now? Because we don't specify the type. Isn't that the current one is the mixed time zone one?
No, there's precision timestamp and precision timestamp TZ, and the difference between the two is more about intent and less about data.
Yeah. So I don't know, precision timestamp with embedded TZ, let's say. Embedded TZ or
My brain hurts.
You could call them localized timestamp.
precision timestamp local.
Yeah, we could think about it.
Yeah.
I feel like I need a document that says here are the 5 different types of timestamps that systems care about and what they are.
Yeah, because the other thing people always say they care about is I need to know if this column is wall clock times or if this column represents instants that actually happened. And that's the one thing we do distinguish between.
Yeah. I think that might be an exercise left for the email or PRs and or Slack and or mail thread. I don't think we're going to solve the timestamp on the next 20 minutes. We feel good about moving on?
Yeah, I think we should just move on.
Yeah. I'm next on the agenda. I feel like, David, you might know this. Is anyone actually running the test cases, the test case files?
Sundeck had code for it. But that was internal. I am probably going to be writing something for my purposes. But that may also end up being internal.
Cool. I guess we're thinking about writing something. We're thinking about writing for something, but we want to be able to run them against data fusion effectively. And I was kind of wondering if one that exists already. But I guess the tangential question is, right now we've got the test format in the nice way to write them. It would be useful to have a serializable format for them to be able to take substrate or take test case, turn it into oh, here's a protobuf message with the expression, the expected result, so we can send it to data fusion or some system that reads Rust and can look at the protos.
Well, then Go has the Go code has a lot of it that you need to do it. Already.
Basically, we don't want to have to write a parser for the test format in Rust again, because the Go already has a parser. But if you could parse them in Go and send them to our data fusion instance or data fusion library that would take that and be able to run them against data fusion itself.
I mean, you can run them easily, and I mean, you basically have to load in the test case, find the functions that well, you don't have to find the functions. Just convert it into the test. Whether you want to convert it, you basically write substrate with the function call, and then send the substrate to data fusion, and you get your result back.
That's what we thought. However, because of the instance of undefined and error, that's the problem. Is that
Well, right, undefined and error. Depending on what your return calls, what your results are, you can catch the results. I've done the same stuff where I've run the tests against converted into SQL, and then ran tests against backends with SQL as well, using a dialect. So you can use this for the validate. Well, actually, the validator uses this, doesn't it?
which
It got
validator?
The Substrate validator got converted over the consumer testing. Consumer testing got No, it's not consumer testing. It's BFG. The big function taxonomy got converted over.
Oh, BFG uses that?
Yeah, because it got completely overhauled when all this stuff was added. So BFT specifically has code that uses all of this stuff to test the functions.
Did it get fully converted over? I didn't.
Yeah, they convert. I think they, or at least they mostly converted it over. I don't know if they finished the job, but we certainly, it should be using.
The last action that ran on the BFT repository was 5 months ago. So it might be there, but it's not running.
Oh, there's dialects in this. What? What?
In BFT?
Yeah.
Yeah.
In YAML.
Yeah.
Why have I not seen this? I feel like a lot of the stuff happened like outside of the core spec, so I never looked at it, and it was never like a strictly made part of the core spec, so it's not core technically. Like, wait, what's this? This is really cool. This is useful.
I didn't know though we had specs for so many dialects in here at all.
Yeah.
Yeah,
Now-
the CI tests used to run through all of those engines and then check that the dialect files were correct. But that was a long time ago.
This is helpful.
Yeah, so these are basically all the options and stuff. The dialects are set up. This is how they're running the tests. So it's basically if this test is valid to run, it's got a dialect. That's interesting.
There are definitely quirks in there that probably need to be cleaned up.
Yeah.
I don't remember what they are anymore either. So I don't think we have anything that's actively running function testing then.
No.
It's
cool,
not
huh?
actively running. I don't think. Well, yeah. I mean, the BFT hasn't run in a while, but it would.
But the existence of dialects is both useful as a starting point, and run tests from Substrate is a good sign of like, okay, how are they doing this? Okay, that's actually really useful. Hello,
Yeah,
Python.
run tests from Substrate is useful because, yeah, it has all the steps that all of the cases handled, that are supported.
Cool. This is good, but also I need a new intern project, but also this is good. Cool. That answers my questions. Yeah, I guess we've got 2 more items.
Yeah.
Yeah.
So I have like two things in flight. It was discussed, I think, briefly previous meeting. So for the build input of hash-on operator, so David had a question about like should other joins also have a specified build side. perhaps only physical ones. I maybe. I think for the physical ones, like there's some, yeah. So like nested loop join or index lookup joins, those may have to distinguish the inputs. Like, so which one is the index or which one is the inner side of the nested loop join. But I don't know whether we want to use the build as a to specify those inputs. So is it build is, well, like it's build is pretty much like everyone understand, like with the especially like hash join semantic. But for the others, like I don't know whether that's a commonly accepted terms. So I guess like we can, if the needs comes up, then we can add it. That's my take.
Yeah,
Go ahead, Vincent.
I agree that using build there doesn't add any clarity. Because in, like, if it's a hash join, build means this is the side I'm building the hash table from. And you're right that like if it's a index join, there's a side that you're doing that has the index that you're doing like the random lookups on.
Yeah.
But you could either say by convention that's the left side, or you could say by convention that's the build side. Those seem to be the same thing to me, where you're just saying we're not using the right word, but there's a convention that you can use to map it. So you might as well use what we have today, which is just use like left. But yeah, I would agree that it would make sense maybe to add a property there someday that's like indexes left or something like that, or I don't know what you would call it, but
yeah,
but build would probably be the word to use.
Okay. Well, I mean, changing just the one for now is fine.
Yeah. So yeah, so that's the one. So I don't know, like I don't know whether this PR can go in or not. So I don't know, like is there like any other updates that needs to be done here, or any more agreement needs to be done, or?
Yeah, I think it's lukewarm, but makes some sense. Let's just get some approvals and let's get it done and move on.
Okay.
For something that's a physical relation, I mean, I can't speak for everyone, but for something that's a physical relation, I'd rather not be too afraid of making clarification.
Yeah, especially because we haven't specified it, just like use the correct behavior. And to the point, I missed this, I'm skimming on it, but it's like you can rewrite the left and right. It is kind of a pain in the ass, and you actually have to like check all the filter conditions on the join. I guess actually this is half, it's probably just quality. Like you can rewrite it, but having an option to be like pick one is relatively straightforward to handle both the producer and the consumer. The producer's just like, oh, I have a build side, just set that. And the consumer's just like, oh, okay. Output shape is the same, but I can, it's not a ton of work, I think.
Yeah. Okay, yeah. So that's that one. This like fetch relation with the ties, the next one. This has been like, yeah, for a while. So the last one of the past meetings, Jack raised the concern that like this fetch needs to be more, it would be better to be more composable semantic. So one of the idea is like, yeah, why don't we, instead of like for sort thing, can we just add some comparison, let's say. So if you specify, for instance, like specify columnist to, and like if the input has like more than n row, then as long as these column lists are equal, then you just keep yielding the result. How about that semantic? But fundamentally, my conclusion is like fundamentally, I mean, the column list is not enough, because you need to compare. You need to compare. At least like you need to tell whether something is equal or not. But equality alone is not is more than just column. You need to, for instance, like string, we need to add some collation, for instance, like, okay, then sort has a collation. So that means like this one also needs some collation, like equality based on respecting the collations, and like God knows what, like there can be like other comparisons. So that made me think it's and also there's also another concept. So we have, so basically this like, comparison now is appearing two other places. So sort, and one is sort, the other one is this the fetch with tie, and then the other one is the physical join, the join key already extended to incorporate collations or other custom thing. I don't know, like what so as far as I can tell, sort doesn't actually incorporate. Does it incorporate the custom function? I mean, custom comparison. Can it be extended? That I need to double check. But yeah, so basically, my sense is somehow for this tie, somehow we need to at least incorporate the sort key comparison semantic. So that's what as is in the PR. We can still debate whether we official, let's say, spec to guarantee the order of the output or not. So I'm fine with the like not guaranteeing. So make it like less stronger, less strict about the operator itself. But at least I think incorporating at least like sort key or the comparison semantic is necessary. I think that is the minimum information to actually support the fetch with the tie.
Yeah, I don't remember why this stalled out, but I do remember the argument that you made, which I was convinced by, that the sort, having the sort on the fetch row means that we can have a nice local operation that indicates like this fetch has to be sorted and output these columns, versus if you have them separate, they can drift from the plan, especially
right. Yeah.
And if you really don't want to handle it in your system, you can just turn the fetch role into a sort followed by a fetch, as long as your system can handle the physical properties and knows not to.
Yeah.
Knows that it can't have to change them.
Yeah. So that's basically what Jack is claiming. But to do that, the fetch needs to understand basically to compare the last rows and and whether they are still the same row with respect to those key.
No, sorry. I think I'm agreeing with you that we should have sorts on the fetch roll. Like you can, if your system doesn't care about it, you can turn it into those independently and track it yourself. But I feel like it is useful in Substrate to have like the concept of like a fetch that is based on some sort of input. Yeah, I can put this back on my queue and I can revisit.
Okay.
I don't feel like there's anything wrong with having a bit of redundancy at this point.
But it's not it's not a sort key, it's a comparison key.
Comparison key.
I mean, it's telling you how to do the comparison in a sort. I mean, you could also say that it's overloaded and also provides the sort. But it's given that the thing is sorted in this particular order, and make it sorted if it's not. Then this is how I determine that two things are equal. Because I have to look at the sort. I have to actually know what those keys are to do the comparison.
Sorry, David, you're saying that the fetch role as defined currently is like the sort is like, no, just treat the inputs as if they're sorted, not sort them yourself.
You could treat it as both.
Yeah, I would say
it works for both. but I mean, it may be useful to clarify that there are two things actually happening. One, which is it's assuming that there is a sort and it needs to be sorted if it's not, and if and after the sort has been taken care of, then it's a comparison.
Yes. Yeah.
I think I might be missing the nuance there, but I don't have a.
The nuance is that you need to know that if it's I'm sorting on employee ID and I get an extra and I get to the end of the record and I want to see if whether or not the next one also has the same employee ID. I need to know that I need to look at the employee ID.
Yep.
So that's a comparison key. It's being used for a second notion in addition to the sort.
Gotcha. Oh yeah, sorry. It's like so the sort fields are you sort on these keys, and then you also have to compare on those sorted columns effectively.
Right. Yeah.
Okay. Okay, yeah, so it is a bit extra.
Yeah. So you can't just separate it into a sort and a filter. It's because you still need the notion of the comparison keys on the fetch.
Yes.
On the
I guess you can like you can I guess not in Kelsey because it's tied, but you could do it as long as you say the fetch is like check these input keys with ties.
Yeah.
The sort is sorting on the expressions. I guess you have to make sure the expressions are omitted. But like you as a system consumer, as a subject consumer, can split it out if you want, as long as you guarantee that it does what it's supposed to do.
Yeah.
There's also why Calcite doesn't do that actually. Calcite just puts the fetch on a sort rel by default, and the more I look at it, the more it makes sense. Anyways, you know, I think if we do this, I think it makes sense to like include it. It's one of those things where the alternative is like having it be split, which I think is worse because then it's like from a consumer perspective, you have to know that these things have to be linked and you have to track physical properties, which we're not ready to do yet. This might be a little redundant having both sort and then like sort like fetch on sort, but I don't think that's a problem as long as we document maybe like why are there also sorts on limits specifically for with tie stuff. Yeah. Cool. I'll put this on my queue to look at again. I've put both of your PRs on my queue actually.
Okay. Yeah. Okay. So
I'm just gonna refresh all the reviews.
yeah, sort field. Okay. So sort field it can be extended or not. Sort direction. No, okay. So sort field is really okay. It captures precisely like how to compare a expression, including the custom.
Yeah, it's got a full expression plus direction, which is what you
right.
need.
Yeah.
Cool.
Yeah. So I mean, technically, like we don't really need direction. All we need, like perhaps like expression and the comparison function reference. That's probably all we need. So we could, if we go like minimalistic, like not reusing these things, and we could do that.
I guess why don't you need direction? Because like I guess when I'm imagining a case where like, oh, I do sort or order by with ties, I just emit a fetch rel only with that set. I don't emit a sort.
Yeah, I mean that's basically if you're okay with the embedding the sort.
I'm
if
okay
you're not
with
okay and go like precisely like a minimal thing that you need with the composing this operator, then the fetch rel needs to be extended with the at least like how you compare the raster. So that in that if given that context, like direction is not needed. So you already know like things are sorted. So all you need is expression and the how you compare comparison function reference. So we could, I don't know, like I'm fine like either way to making change, but yeah.
Cool. If we are close to time.
Yeah. So please take a look, and then if you have any other thoughts or comments, like let me know. I'll happy to update.
Yeah. Awesome. Cool. Thanks so much, everyone.
Right. Thank you, everyone.